Hi everybody, this is Mrs. Ellsworth, and we are going to be talking about surface areas of cylinders. And a good example of a cylinder, I like to use a soup can example quite a bit because so often we have taken off labels off of there either to recycle or else to go and turn in for some school supplies. And so I like looking at this one because if you think about it, there are two circles, the top and the bottom of the can, and we know how to find the area of a circle. Okay, and the other thing is the soup can label. And so if you really think about it, this distance around the top is the same thing as the distance right here. And so that's circumference. So we can use circumference and then also the height of the can to calculate the surface area of a cylinder. Here's another diagram. I kind of like how this one looks too. They give you, all you need is just two measurements, the radius and the height of a can. Okay, and so then now they're kind of unfolding this net around the can, and so they're showing you here is the circle for the top of the can, and here's a circle for the bottom of the can, and here is the label of it. It's kind of a long skinny label for that one, and they're showing that idea of circumference being this length because that is the distance around this top is this length of this, and then of course the height of the can. Okay. So let's go ahead and use this information. Okay, so here's our soup can label, okay, wrapped around a cylinder. Okay, so when we go and spread it out, I said that 2 pi r is the equation for a circumference. You've probably learned it as 2 times r, which is diameter times pi. So they're breaking it down. And the reason why is because most of these problems in 7th grade go and give you radius. Not always, but quite frequently. So we're just going with radius so that we've got less variables to worry about. Okay, so let's go ahead and look at this. So area of one of the circles is pi r squared. Okay, so that's one circle. The other circle would be pi r squared. So we can actually add these together and get 2 pi r squareds. And then we've also got this this label on the can, which is going to be the so this label on the can, you quite often think it's base times height, but we don't have a base on here. We have to recognize that it's pi r 2 pi r, excuse me, and then it's also times the height. And again, I thought, well, maybe you can't remember circumference, so it's either d times pi, that's the diameter, and what is the diameter? That's 2 radiuses, right? 2 radiuses times pi. So that's how they got that information. On some of the websites, you'll see it written like this. Okay, 2 pi r squared. Again, that's for the two circles of the can, the top and the bottom. And then right here is the 2 pi r, which is the circumference times the height. I write it like this, and so you'll always see mine written like this, 2 times pi r squared, which is area of the circle. There's two circles, and then 2 pi r is of course circumference, and then times the height of the whole cylinder. Okay, so let's go ahead and look at some of these. Okay, and your assignment, I believe, is 4, 5, 6, 7, and 8, and then there's an extra credit question too. We're going to now look at number 4. So let's go ahead and look at our formula again. 2 pi r squared, 2 pi rh, okay? And so what is our radius? Our radius is 6, so we'll go and substitute 6 in for the two radiuses here, and the height of the whole thing is 10. And I happen to have this pre-written up here. Okay, so we'll take 2 times the quantity of 3.14 for pi, and 6 is our radius, and we're going to square that. Okay, then we've got 2 again, and pi is 3.14, and our radius of our circle is 6, and the height of it is 10. So I went and did some calculating for you, and so you see that I did go out to the 100th here. Well, of course you should. Because you should always use what numbers are in your calculator when they're kind of small like this for decimals, and then you can go and round it later on to 602.9 square yards. Okay, make sure you get that little yards and then with a little 2 there. because this is area. And again, area is always a squared unit. Okay, I just got to look at this one here too. Again, remember here's our formula, and this is not the radius, this is the diameter. So you'll have to take that in half. So your radius is going to be 1.5 on both of those situations, and then your height is 18. Just for a little hint there. And also for more of a hint on that one, that number, when you go and calculate, it's going to be between 180 and 200 for a hint. Okay? Just to double check and make sure you're doing them right. And don't forget those odd numbers are in the back of the book. Okay, and here's one last thing. Okay, number 15 is your extra credit. And number 15, it's asking for a mail tube shown as made of cardboard and has plastic end caps. Approximately what % of the surface area of the mail tube is cardboard? So I just want to remind you, what does this stand for? This stands for the area of a circle. Okay, but there's two of them. So that's that part of the formula. And this right here is the circumference times the height. So that's the label of your soup can, or in this case, it's the cardboard. So when you go and figure this out, you can go back and look on that yellow resource sheet that we have for how to calculate percents, because remember, it's a part divided by the whole. This is the whole equation here. The part would just be the cardboard amount. Anyway, that's all that I've got for you now, and here's your assignment 4 through 8. Number 15 is extra credit, so there you go, and I will see you when I see you, but otherwise I'll see you online. Bye-bye.